All right, we're going to be talking about solving rational expressions. So I'm going to look at kind of two different ways to do that, or a few different ways. The first is if we have a common denominator. So over here, we have two rational expressions that are equal. This is actually a proportion. But if I have my denominator is the same, then I can actually just work on my numerator. So if the denominator is the same, I'm just going to solve the numerator. And then let's change this to be 8 here. So this is x plus 8. And so what I'm going to do is I'm going to subtract 8, and I get negative 3 equals x. And there would be my answer. When we're dealing with solving rational expressions, we want to make sure that we understand that the denominator can't be 0. So the value that's going to make that equal to 0 is a value that does not work. Okay? So if I end up with negative 2 just does not work. And so we want to make sure if my answer was negative 2, that's what we call an extraneous solution. It's a solution that looks like it works, but when you plug it back in, you get some kind of mathematical error. So we're going to go over here. Here's our example 1. We have 5/12 minus 1 over 2x equals 1 over 3x. Now, the first approach I'm going to show you is kind of multiplying by a common denominator. So most people don't like working with fractions, so let's not. Let's get rid of that denominator. Let's get it into just a single algebraic expression. Now, when you're doing that, you do have to understand there is a value here. Because I have an x in the denominator, there's a value of x. That does not work. In this case, x cannot equal 0. Okay? So when we're solving this, we want to make sure that if we get that as one of our solutions, that's an extraneous solution. So if I'm looking here, I have 12, 2x, and 3x. I need to find that common denominator. Well, the common multiple of 12, 2, and 3 is 12. And the common multiple of 1, x, and x is x. So what we're going to do is we're going to multiply everything by 12x. That's my common denominator here. Okay? So if I multiply 12x by 5/12, the 12s cancel out, and I end up with 5x. Well, let's do this all out. So this becomes 12x times 5 over 12 minus 12x times 1 over 2x equals 12x over 3x. And then we're just going to kind of cancel out here. And so I end up with 5x minus 6 equals 4. And now we're at a simple algebraic expression, algebraic equation. We're going to add our 6 here. 5x equals 10. Divide by 5. X equals 2. I compare that to what x cannot be. They're different. So what's going to make this equal when I solve for it is 2. Okay? We're going to use that same approach here. This is the same thing as getting that common denominator, because here you can see I would actually have a common denominator of 12x. So I would multiply the top by 5, this by 6, this by 4, and I'd have that common denominator. Okay? So here I'm gonna work on doing that same kind of expression here. I notice that I have an x and an x squared in my denominator. So my common denominator is x squared, and x cannot equal 0 once again. Okay? So what makes that 0, 0? What makes that 0, 0? Okay? So now I'm going to multiply everything by x squared. Okay? So 1 times x squared is x squared. X squared divided by x, or multiplied by 1x, is x equals, and then the x squareds cancel out here, 12. Now this is a quadratic. So we want to either factor or use the quadratic formula or complete the square, or any of those methods. So the first thing I'm going to do is I'm going to get this equal to 0. X squared minus x minus 12 equals 0. Well, are there factors of 12 that subtract to give me negative 1? Well, the answer is yes. So I have x minus 4, x plus 3. So I have negative 4, positive 3. That will give me my negative 1. So now I look at each piece of these. What makes this 0? What makes this 0? So I'm going to set them equal to 0 and solve. Most of you probably are doing this in your head, and that's awesome. So I'm going to add 4, x equals 4, subtract 3, x equals negative 3. So I have two answers on this one. I check this back against my value that x cannot be. They're different. Here's my solutions. I could plug them back in, double check just to make sure they work. For time purposes, we're just going to kind of move on. So in our last example here, we have a proportion. We have 4 over x plus 2 equals 3 over x plus 1. Now, if I can get this to be a fraction equals a fraction, what we're going to do here is we're actually going to cross multiply. So I'm going to look at the values x cannot be. X cannot be, well, what makes this 0? Negative 2. What makes this 0? Negative 1. So my answer can't be negative 2 or negative 1. All right? So I'm going to take this, I'm going to cross multiply. So I have 4 times x plus 1 equals 3 times x plus 2. I'm going to distribute my 4 and 3. 4x plus 4 equals 3x plus 6. I'm now going to get my x's on the same side. So I'm going to take my smaller and move it. So 3x, I'm going to subtract 3x from both sides. X plus 4 equals 6. Subtract my 4, subtract my 4. X equals 2. It's different than what x can't be. So the main thing when you're solving rational expressions is either multiplying by a common denominator so you can get rid of it as a fraction, or finding it as a common denominator and then just work on the numerator. If you can get it into a fraction equals a fraction, you can cross multiply. So that's solving rational equations.